It's the quarantine season. We're all trying our best to flatten the curve by social distancing and staying home to prevent this further spread of COVID 19. So let's speak hypothetically. Suppose you're about to get a drink of water because you're thirsty, and you notice that the bottle of water has a lower temperature or higher than the surrounding area. How can that be? Interesting question, me number two. Well, that's because of an interesting phenomenon called heat capacity. Heat capacity, often denoted by a capital C, is the amount of heat energy needed to raise a substance by 1 degree Celsius. This is why a bottle of water, like the one I have in my hand right now, conveniently, can hold a specific amount of temperature despite the room's temperature. Heat capacity allows it to take in heat energy without changing the temperature of the bottle. To calculate heat capacity, scientists and students use the formula heat capacity is equal to mass times specific heat capacity. Now, I know what you're thinking. What in the world is specific heat capacity, random video guy? Well, specific heat capacity, often denoted as common C, is the amount of heat energy required to raise 1 gram of a substance by 1 degree Celsius. Huh? Aren't those two definitions the same? No, there's one key difference. Heat capacity does depend on the value of the mass of the substance, as it is an extensive property, while specific heat capacity does not. Scientists just added the specific because, well, there's a specified unit mass. To find specific heat capacity, we can arrange a common formula. Change in heat energy is equal to mass multiplied by specific heat capacity multiplied by the change in temperature to get specific heat capacity is equal to change in heat energy divided by mass multiplied by the change in temperature. The higher a specific heat capacity is, the more energy it can store without a raise in temperature. All good, but how is this useful in real life? I mean, is it something pointless to learn? Well, knowing the specific heat capacity of a substance can be very useful. For example, knowing the specific heat capacity of a particular substance can help to determine if it's a good retainer of heat or not, which can then be used to evaluate whether the specific substance that we have chosen can be used for creating cooking utensils and even scientific equipment. Yes, you're using the science to create the science.